Welcome to my kcse revision channel. Marida James, Girls Boys High School. Kindly subscribe my channel, click the notification bell to get notified once I upload a new video. Today we are looking at mathematics, the area of our curve, kcse revision 2023. The diagram below shows a sketch of a line y is equals to 3x and the line and the curve y is equals to 4 minus x squared intersecting at point P and Q. So this is a line y is equals to 3x and this is the curve y is equals to 4 minus x squared. So our first question, find the coordinates of P and Q. So to get the coordinates of P and Q, to get the coordinates of P and Q, we have a line y is equals to 3x and the curve y is equals to 4 minus x squared. So we can equate the two equations here by saying that 4 minus x squared, this one is equivalent to 3x. If we collect the like terms together, collecting the like terms, we have x squared minus, we have x squared plus 3x minus 4, and this one is equivalent to 0. So we can have a product which is equals to, the product is 1 times negative 4, so we have negative 4, and the sum is equals to 3. The factors which can give us a product of negative 4 and the sum of 3 is 4 positive 4x and the negative 1x. So we write now our equation as x squared plus 4x minus 1x minus 4, and this one is equivalent to 0. So we have as a x into x plus 4 minus 1 into x plus 4, and this one is equivalent to 0. So you write as x minus 1 into bracket x plus 4 is equals to 0. We can now find from here where we have x minus 1 is equals to 0, the value of x is equals to 1. We have x plus 4 is equals to 0. From here, the value of x is equals to negative 4. Now we have x is equals to negative 4 and x is equals to 1. So we can use either the equation of a line y is equals to 3x to find the value of y, or you can use y is equals to 4 minus x squared to find the value of y. So this one is the easiest, so we can use the first equation, y is equals to 3x. When x is equals to 1, the value of y is equals to 3 into 1, which is equivalent to, that one is equivalent to 3. When x is equals to negative 4, y is equals to 3 into negative 4, and this one is giving us negative 12. Now to get the coordinates of P, we have the coordinates of P, so we have the coordinates of P, this one here, it is negative x is equals to 1, y is equals to 3. So the coordinates will be 1, 3. To have the coordinates of Q, y is equals to negative 4, already we have. negative 4 to 1. So we have negative 4 on the x-axis. The value of x is equal to negative 4. The value of x is equal to negative 1. So we have negative 4, then we have 1. So q is equal to negative 4, 12. So we have this one is negative 4, comma, negative 12. Those are the coordinates. Those are the coordinates of P, which is 1, 3, and the Q is negative 4, 12. Correct? We proceed. Given that Qn is perpendicular, given that Qn, we have Qn here. This one is perpendicular to the x-axis. Is perpendicular to the x-axis where it makes an angle of 90 degrees. Calculate the area bounded by the curve, the x-axis, and the line Qn. The area bounded by the curve, the x-axis, y is equal to 4 minus x squared, and the line Qn. So in short, we are talking of this area. We are talking of this area here. We are talking of that area. And how do you have that area? We know that at x-axis, y is equal to 0. So at x-axis is equal to 0. So we write 4 minus x squared. This one is equal to 0. We simplify prime factor of this one. Simplify this one. We factorize 4 minus x squared. So we have this is 2 minus x. Then we have 2 plus x. This one is equal to, that one is giving us 0. So from there, the value of x is equal to 2, or the value of x is equal to negative 2. We have x is equal to positive 2. It is on positive, is on this side of 0, which is on the right hand side from 0, and x is equal to negative 2. So we have it is at the left hand side from 0. So the region we are talking is now negative 4 to negative 2. So we ignore this one because it's on the positive side. We take now the limits now here. We are integrating. We integrate now the curve from negative 4. We have negative 4 to negative 2. Negative 2, and the curve is 4 minus x squared. So if we integrate that, integrate this one from that one is giving us 4 is we have as 4x minus x raised to power 3 over 3, and the limits we are of integration is negative 4, and then we have negative 2. When x is equal to negative 2, we can have 4 into negative 2 minus negative 2, this one raised to power 3 all over 3, minus when x is equal to negative 4. So we can have 4 minus 4 minus negative 4 raised to power 3 divided by 3. Simplifying this side is giving us negative 5 and 1 over 3. And on this side we have positive 5 and 1 over 3. So we have negative 5, 1 over 3 minus 5 and 1 over 3. So we subtract here, and we have this one as negative 10, 2 all over 3. It is negative to show that the area of this region is below the curve. So it is below the x-axis. The x-axis, that's why we have a negative. So we ignore this negative. Our area is equal to be 10, 2 all over 3 square units. That is the area bounded by the curve, the x-axis, and the line Qn. We proceed. Roman 2, the area of the shaded region that lies below the x-axis. The area of the shaded region that lies below the x-axis the area of the shaded region that lies below the x-axis, the area of the shaded region that lies below the x-axis, this is the area of the shaded region which lies below the x-axis. How do you get that one? You get the area of this triangle, NOQ, the area of triangle NOQ. Then now you subtract the area bounded by the curve, the x-axis and the line QN. So the area of a triangle first, it is the area of a curve and the line y is equals to the area of a curve. The area of this triangle we get by the area, the area between the curve y is equals to 4 minus x squared and the line y is equals to 3x. So the area of this triangle, we just find the area, the range, the x-axis and the line y is equals to 3. So we integrate that one, the x-axis and the line y is equals to 3. The area of this triangle, -4 to 0. So we integrate this one, -4 to 0. It is the area of the x-axis and the line y is equals to 3. So we are integrating this one, x, the line y is equals to 3. Of course, we have dx of that one. So we integrate that one, we can have the integral. We have this is 3x squared we divide by 2. The limit is between -4 and 0. The limit is between -4 and 0. So when x is equals to 0, we have this one as 0. Then we have 0 squared all over 3 minus, when x is equals to -4, we have 3. Then we have -4. We have -4 square. Then we divide that one by 2. And of course now this one is giving us is 0. Work out that one, we can have as 24. And therefore the area of this one is equals to the 24. It is a negative. A negative will show you that the area of this triangle is below the x-axis. Now to get the area of the shaded region here, it is the area of this triangle, which is 24, minus the area bounded by the curve, the x-axis, and the line QN. The line bounded by the curve, the x-axis, we already find at Roman 1, this one here. The area of a triangle, we have got this one as 24 square unit. Therefore, the area of this shaded region now, it is the area of this triangle, which is 24, minus the area of this side, which is the area bounded by the curve, the x-axis, and the line QN. So we subtract 10 and 2 all over 3. So if you subtract that one, we get that area as 13 and 1 over 3. 13 1 over 3 square units. Correct? The last part, we are supposed to find the area of the region enclosed by the curve y is equals to 4 minus x squared. Area enclosed by the curve y is equals to 4 minus x squared. The line y is equals to x. The line y is equals to x. And the x-axis. And the x-axis. Simply, we are now talking of the area of this shaded region. So, how do you have the area of this shaded region? So, the area of this shaded region now, we have the area of this shaded region we found as the integral from -2 to 0. So we can have -2 to 0, such that we can now to find the area of this part. The area of this shaded region, it is the area below the curve and the area above the curve. So we already have this area, which is 13 and 1 over 3, this area. And now we are finding the area between negative 2 and 0, and the curve y is equals to be 4 minus x. So the area of the area above the curve, which is shaded now, the area above the x-axis, which is shaded, we have this negative 2 to 0, and the curve y is equals to 4 minus x squared. So first we find this area here, and then now we add the area below the curve. We can have the total area of that shaded region. So we can integrate now that one as from, we integrate this one from negative 2 to 0. So we have this negative 2 to 0, and then the area of the equation of our curve is 4 minus x squared. So if we integrate that, we can, this one is equals to p, it is 4x minus x cubed all over 3, and then we have negative 2 to 0. When x is equals to 0, we have 4 into bracket 0 minus 4 minus 0 raised to power 3 over 3 minus, now when x is equals to 2. So we have 4 into negative 2 minus negative 2. This one is cubed. Then we divide that one by 3. And if you simplify that and work out this one correct from the calculator, you will get this one as 0. We have this one as 0. Then minus, we can have a negative there, 5 and 1 over 3. So we assume a negative, we assume this negative, and then we have that area as 5 and 1 over 3 square units. Now that 5 and 1 over 3 square units, it is the area above the x-axis. And the line x is equals to negative 2, x is equals to 0. Now to get the area enclosed by the curve, the area enclosed by the curve, it is the area below the x-axis plus the area above the x-axis. So the area below, we had that the area below we have that one as the area below we had that one as 13. There is somewhere here. The area below we have this one as 13. So we take this one as 13. So we have 13, 1 over 3, plus now the area above, which is 5, and 1 over 3. And therefore that one gives us the total area, which is 18 and 2 over 3 square units. Kindly follow my channel, click the notification bell. You get notified once I upload a new video. Thank you.